Good afternoon, students. This afternoon, actually, I would like to discuss the NCRT S block elements question answers from the book, okay, from the textbook. So, because a lot of questions, if you understand the concepts from these question answers, you'll be able to answer many from the neat questions, okay. So, now, question number one. What are the common physical and chemical features of alkali metals? We know that in S block, there are two groups are there in S block. Number one, alkali metals, and two, alkaline earth metals. Okay, so alkali metals we have lithium, sodium, potassium, rubidium, cesium, and francium. And alkaline earth metals, so we have beryllium, um, magnesium, calcium, strontium, barium, and radium. Okay, these are the metals present in S block elements, alkali metals and alkaline earth metals. And alkaline, alkali metals, if you look at the, they have in the last, the valence shell, they have only one electron, whereas alkaline earth metals, they have in their valence shell, they have two electrons. Okay, so NS1 is the valence electronic configuration for alkali metals, and NS2 for alkaline earth metals. So alkali metals, then the oxidation state is +1, and then alkaline earth metals +2. Okay. The first question is they ask, what are the common physical and chemical features of alkali metals? So alkali metals is soft. It is soft, and then cut them easily, and they are alkali metals are light colored. They mostly appear silvery white. Atomic size, if you look at the atomic size, it's larger for alkali metals. If you take any period, you know that there are 7 periods in the periodic table, and if you take any period, the largest element in that period will be the alkali metals. The first elements in that particular period, the alkali metals are larger in size, and because they are larger in size, their density is less. And then density, if you consider the density of alkali metals, they increases down the group, except for potassium. Potassium, what are the, like for example, if you look at this one, the order by which the density increases is first lithium, followed by potassium, instead of sodium, followed by potassium, followed by sodium, and then we have the regular elements, rubidium, cesium, and then francium. Okay, here there is a potassium and sodium switched over. Okay, why? Because the presence of d orbitals in potassium makes the volume of potassium bigger, so its density is less. Okay, so remember that order. And then alkali metals, they have only one electron. Why they are soft? Alkali metals, why they are soft? They have only one electrons in their valence shell, and when they form metallic bonding, you know how the metallic bondings are formed. The metallic bondings are formed, one atom of the metal combines, and the atoms, one atom after other, they combines and they share the electrons, and they produce metallic bonding. Since they have only one electron, their metallic bonding is weak compared to other metals. They are weak. That's the reason they have soft property. They are soft, and also they have low boiling and low melting point compared to other metals. Okay, so they are weak, and metallic bonding is weak, so they are soft. And then these alkali metals, when you expose to color, flame, if it's exposed to flame, they produce color. That is because the electrons in the present in the last orbit, that is a valence shell, they easily excited by the heat of the flame. So they give different colors, like lithium crimson red, lithium, sodium, golden yellow, potassium, violet, rubidium violet, cesium, blue. Okay, so they give colors when you introduce these metals into in flames. And then this metals, like they're generally the metals, alkali metals, they have the tendency to lose electrons very easily. So potassium and cesium, these metals lose electrons, alkali metals lose electrons very easily when they irradiated with light. So they exhibit a photoelectric effect. Okay, they exhibit photoelectric effect. Now, if you look at the atomic size, as is there's generally, as you go down the group, atomic size increases. Lithium, sodium, potassium, rubidium, cesium, and francium. So if you look at the order of their ionic size, okay, whether it is atom or atomic radius or ionic radius, both increases down the group. So lithium plus or lithium will be the smallest, followed by sodium, followed by potassium, followed by rubidium, followed by cesium, followed by francium. Okay, so this is the order in which the atomic size increases. And if you look at the ionic size, the same thing. Okay, so lithium plus so lithium plus ionic radius. Now I'll just put this one. So atomic radius increases. And then ionic radius increases. So ionic radius increases. Of course, here we are not going to discuss francium. Okay. Now, so generally ionic radius, down the group increases from lithium to cesium. The smallest cation is lithium. The largest cation is cesium. Remember that. And then metallic character. If you look at the metallic character, again it increases just like the first one, from lithium to cesium or francium. Let's say lithium to cesium. I'm going to skip francium because francium is a radioactive element. So we are going to skip francium. So metallic character. Okay. So if you take a metallic character, it increases down the group. Because you can remove the electron from cesium very easily compared to lithium. So compared to lithium, cesium donates its electron very easily. So the whichever metal which donates its electron easily, metallic character increases. Okay. And then similarly, photoelectric effect. Photoelectric effect, again, it increases according to the order. Lithium shows least photoelectric effect, whereas cesium shows the highest photoelectric effect. Okay, and then these are the some of the properties. And then if you look at the chemical properties, alkali metals, when they react with water, they produce metal hydroxides and hydrogen gas. Okay, metal hydroxide and hydrogen gas they produce. And if they react, and also alkali metals undergo reaction in air. Okay, it reacts with oxygen and also nitrogen. When alkali metals react with oxygen, lithium forms. So lithium, generally lithium gives lithium oxide. Lithium oxide is produced, and then sodium reacts with oxygen, gives a sodium peroxide, Na2O2. Okay, so Na2O2. Whereas other metals, alkali metals like potassium, rubidium, cesium, these metals gives a superoxide. So potassium, rubidium, and cesium gives superoxide. Okay, so I'm going to give here metal oxides. Metal peroxides. And then rubidium, potassium, rubidium, cesium gives superoxide. Superoxide is MO2. Okay, superoxide, metal superoxides. Okay, so this is the reactivity in the presence of in the air. Okay, these metals reacts with oxygen, produces lithium, mostly gives metal oxide, Li2O. Sodium mostly gives peroxide, Na2O2, and potassium, rubidium, cesium gives superoxide. Okay, and among this one, superoxides are actually colorful. They are paramagnetic. They are paramagnetic because they have lone pair of electron. I'm sorry, one unpaired electron. One unpaired electron, and they are colorful, colored compounds. So superoxides, among the oxides, metal oxide and metal peroxides, they are colorless, whereas superoxides are colored because of their paramagnetic substances, and they contain one unpaired electron. The ions, if you look at the ions here, metal oxide. Okay, so metal oxide ion is O2 minus. So oxide O2 minus, peroxide O2 2 minus, peroxide O2 minus, superoxide O2 minus. Remember that one. Okay, so oxide ion is O2 minus. O2 minus. And then peroxide is O2 2 minus. Then your superoxide is O2 minus. Okay, remember that O2 minus, oxide is O2 minus, peroxide is O2 2 minus, and superoxide is O2 minus. So remember that one. So superoxides are O2 minus, and they have, for example, if you tell what is the formula for cesium superoxide. Okay, cesium superoxide will be CsO2. So cesium peroxide will be CS2O2. And cesium oxide will be CSO. Okay, I'm sorry, CS2O. CS2O. Remember that one. If it is oxide, you have O2 minus, peroxide O2 2 minus, and superoxide O2 minus. And then alkali metals react with water, forms dihydrogen and hydroxides. Okay, if you look at the reactivity of these alkali metals in water, if you look at this reactivity of the reactivity in with water, reactive with water. Okay, high alkali metals reactivity with water. So lithium going to be the least reactive. Lithium is least reactive, followed by sodium, followed by potassium, followed by rubidium, followed by cesium. Okay, so reactivity, because lithium reacts least, whereas cesium reacts the most. Okay, so explosively cesium reacts, lithium, sodium kind of slow, whereas potassium, rubidium, cesium and all, they explode when you drop these metal in water. So the reactivity is very high with water. So when they react with water, they produce their hydroxides, and hydrogen gas will be liberated. And also general reactivity of alkali metals also follows this trend. Yeah, lithium. So lithium followed by sodium, next to potassium, rubidium and cesium. Okay. So now it is, let us say here, let's look at here. So the product is lithium hydroxide is formed when these alkali metals react with water. Okay, let us look at the hydroxides. Lithium hydroxide we have, um, and then if you look at the basicity of these basic strength, if you look at the basic strength of these hydroxides, okay, basic strength of hydroxide. Basic strength of hydroxides, if you consider, they have lithium hydroxide is the least, and then followed by sodium hydroxide, followed by potassium hydroxide, followed by rubidium hydroxide, followed by cesium hydroxide. Okay, so basic strength of hydroxides of alkali metals increases this order. Cesium hydroxide, there's several ways you can add the cesium hydroxide. This because the size of cesium is bigger, and they are cesium OH. When you dissolve it in water, they easily dissociates into cesium plus and OH minus ion. Okay, because of the size of here, OH is same because size of cesium increases. They are actually here CSOH ionic character increases. They easily give solubility also. Cesium hydroxide is easily soluble and they breaks into cesium plus and OH minus. Since cesium OH gives easily donates OH minus ion, it is highly, its basic strength is high. In another way you can say is lattice energy. When you go from lithium OH to cesium OH, the lattice energy decreases. Okay, so it means lithium OH is strong, the lattice energy is more. So what happens, lithium hydroxide compared to cesium OH is less soluble. If the lattice energy is more, they don't want to come out of the lattice. So lithium hydroxide will donate its OH slowly, or so the strength is less, whereas cesium hydroxide strength is higher. So it is a basis, the basic strength increases from lithium hydroxide to cesium hydroxide. And similarly, if you look at metal hydrates, dihydrogen, actually these alkali metals react with hydrogen, produces metal hydrides. Okay, metal hydrides, they also have metal hydrides they form, and if you compare let us compare lithium hydride. Okay, lithium hydride, if you compare, actually it is more stable compared to sodium hydride, compared to potassium hydride, compared to rubidium hydride, compared to cesium hydride. Okay, the hydride, because the stability, if you compare the stability of these hydrides, or you can put it as the thermal stability of these hydrides, lithium hydride will be more stable because this lattice energy is strong compared to cesium hydride. So thermal stability is this. Now look at hydride. Now when suppose in the third, since LiH is more stable, it means you cannot easily remove H minus from Li. Cesium H it can donate its hydride ion very easily compared to lithium. Okay, so if you look at reactivity of this, reactivity of hydrides. If you look at the reactivity of hydrides, it will be the opposite order. Okay, so lithium hydride will be the least reactive compared to sodium hydride, compared to potassium hydride, followed which compared to rubidium hydride, compared to cesium hydride. Okay, so keep this one. And next one is alkali metal reaction with halogens. Okay, so when they react, these metals, when they react with halogens, they produce halides, metal halides. And here there are some properties, a covalent character and ionic character comes into picture. And for that, if you look at whether the formed metal halide or alkali metal halide is ionic or covalent. Okay, how will you find out that? For that, we have to follow the Fajon's rule. Okay, according to Fajon's rule, now what is according to Fajon's rule? Just give me a second. I just want to show this. Okay, I hope you can see this diagram. According to Fajon's rule, if the cation is bigger, compared to among the cation, if the size of the cation is bigger, generally they form covalent character. Okay, if the size of the cation is smaller, as the size of the cation decreases, it's going to form covalent compounds. Okay, why? There is a property called polarizability. What is polarizability? It is a property in which a cation pull the electron cloud towards itself. Okay, destabilize or delocalize the electron cloud by pulling the electron cloud towards itself. Okay, so that is more when the size of the cation is small. When the size is small, it's going to pull the cation, anionic cloud towards itself and destabilize, make the electrons towards itself. Okay, so ionic bond abdina general transfer of electron should take place. Transfer of electron, so two ions will be anion, cation will be formed. There will be attraction between these two ions. But if the ion is small, the cation is smaller, this is going to pull the electron clouds towards itself and change that ionic bond into, and then they are introducing covalent character to that species. For example, sodium, if you compare Na plus and chloride ion, we are going to explore sodium Na plus, Mg2 plus, Al3 plus. அப்படி பார்க்கும்போது பார்த்தீங்கன்னா anion same, Cl minus, Cl minus, Cl minus, but the cation is changing size and also charge density. Na plus only 1 plus and size is bigger. Okay, when it forms with compound with Cl minus, it's going to form ionic compound. When you go to Mg2 plus, size decreases and strength of the ion also decreases. It is going to pull the electrons towards itself. So it's going to introduce covalent character. Okay, and then Al3 plus. Okay, so the size of the cation is still smaller and the charge density is also more. So it's going to depolarize the electron cloud, and so polarizability is very higher and it's going to form covalent compound. So AlCl3 is more of covalent character than ionic character. Okay, that one. So based on the charge of the size and charge of the cation. So covalent character form பண்ணனும்னா எப்படி இருக்கணும்? Size வந்து small. If the size of the cation is smaller, it's going to form covalent compound. At the same time, if the charge of the cation also more, then so if the charge of the cation is more, size is going to be also be, generally it will be smaller. So if the charge density of the cation is more, it means small size and more size, more charge. Then it's going to polarize the anion much. Okay. Now come to the size of the anion. Okay, we fix the size of the cation. Cation வந்து ஒரு size வச்சுக்கிறோம். AlCl3 is given and we change the anion from F minus to Br minus. இதில் பார்த்தீங்க fluoride ion வந்து small size come, and then அதுக்கு next வந்து chloride ion, then followed by bromide and then iodide varo. Okay, so when the anion size increases, ஆனாலும் it is going to it's going to be the bond, the electron cloud is going to be polarized more. Okay, so cation size சின்னதா இருந்தா polarizability ஜாஸ்தி, அதே anion size பெருசா இருந்தா polarizability ஜாஸ்தி. So what happens if the cation is smaller, it's going to form covalent bond. If the anion is bigger, it's going to form covalent compound. Okay, opposite is for ionic compound அப்படின்னா the cation should be bigger, anion should be smaller. Cation should be bigger, anion should be smaller. So this is the Pajon's rule. Okay, this will help you in many areas. So let us continue that. Okay, now alkali metals, what happens? They are going to react with halogens and form metal halides. Now in this one, they had given actually among the halides, we saw, I mean, size of the among the, there are two things, let's say. Cation size, let us look at. Okay, cation size, if you look at, cation size going to be, lithium is the smallest, lithium plus already I have made, let us copy that one. So cation size and anion size, let us take it. So let us consider the cation size here. So cation size, we know lithium is the smallest, cesium is the largest. Okay, so as the cationic, and then anionic size, look at the anionic size. Okay, anionic size. We know that F minus, and then F followed by, F is the smallest anion, followed by chloride ion, followed by bromide ion, followed by bromide ion, followed by iodide ion. Okay, so this is the anionic size increase. Okay, so cation size increases from lithium to cesium, anion size increases from fluoride to iodide. Okay, now we are going to just make compounds between these two halides and metal ion. Okay, let us consider halide MCl, metal halides, metal chloride. Okay, so if you consider metal chlorides, okay, so now we are going to consider, so let us consider chloride is fixed. Lithium chloride, sodium chloride, potassium chloride, rubidium chloride, cesium chloride. All chloride ion, anion is fixed, but the size of the cation is increasing. Okay, so already, so what is the smallest ion? Lithium ion. This is the smallest ion. So when the ionic size is less, it's going to be covalent, we saw. So metal, so covalent character. So covalent character increases, okay, in the order. Okay, how the covalent character increases, lithium Cl will be covalent, okay, followed by NaCl, followed by KCl, followed by rubidium Cl, followed by cesium Cl. Okay, so covalent character increases. Why? Because the size of the cation increases. Okay, the reason is the size of the cation increases. Size of the cation increases. Okay. Now, look at suppose if we compare among the halides. Okay, we are going to fix the metal ion and change the halide ion. Now, what happens? Covalent character. Okay, I'm going to write decreases. Covalent character decreases when lithium fluoride, if you compare lithium fluoride is ionic. Okay, next lithium bromide, lithium chloride, then lithium bromide, then lithium iodide. Lithium iodide. Now, covalent character, when you compare lithium fluoride, lithium chloride, lithium bromide, lithium iodide, now size of the cation is fixed. Size of the cation is fixed. I'm sorry. Covalent character no, I'm sorry. Covalent character increases only here. From lithium fluoride will be less covalent compared to lithium chloride, compared to lithium fluoride, followed by lithium bromide, and then lithium iodide. So covalent character, because we saw already anion size of the இங்க first வந்து covalent character increases. ஏன் increase ஆகுது? Size of the cation increase ஆகுது. I'm sorry, students. I'm sorry. There is a mistake here. Covalent character, already we saw covalent size of, if the size of the cation is smaller, cation size smaller. Okay, cation size smaller இருந்தது அப்படின்னா smaller. Cation size smaller means, it means covalent. Okay, so covalent character, இப்போ இங்க வந்து size of the cation வந்து increase ஆகுது. So what happens? Covalent character decreases. Covalent character decrease ஆகணும். From lithium chloride to cesium chloride, when we go, covalent character should decrease because size of the cation increases. நம்ம ஏற்கனவே பார்த்தோம் cation size, with the cation size is smaller, so it's going to form covalent compounds. Okay, if the cation size is bigger, it's going to form ionic compound. So cation size smaller, covalent compound. Same thing. So if the anion size is bigger, anion size is bigger or larger, the anion size is bigger, it's going to form covalent compounds. Okay, so covalent character lithium cesium வரைக்கும் பார்க்கும்போது பாத்தீங்கன்னா chloride ion is same size, size of the cation வந்து increase ஆகுது. So if the size of the cation increases means covalent character decrease ஆகணும், ionic character increase ஆகணும். I can put this one in two ways. The same trend will form. Covalent character decrease ஆகிறதுக்கு இதே trend தான், and ionic character increase ஆகிறதுக்கு இதே trend தான். Ionic character increases இதே trend தான். Both are same trend. Okay, so okay, now look at the again look at now compare the anions. Now anion size நான் சொன்ன bigger covalent compounds form ஆகும் அப்படின்னு. So here அதேதான் பார்க்குது. என்ன ஆகுது, from fluoride to iodide நம்ம போகும்போது size of the anion பெருசாகுது. So பெருசான anion பெருசான polarizability வந்து என்ன ஆகும், higher ஆகும். I minusக்கு higher polarizability, Fக்கு வந்து F minusக்கு less polarizability. So if the polarizability is more, then it going to form covalent compound. So the size இங்க பாத்தீங்க அப்படின்னா the size of the anion increases. Size of the anion increases, so covalent character increases here. Okay, so keep that in mind. Whereas in lithium chloride lithium chloride to cesium chloride, covalent character decreases. So which is more covalent here? When you compare lithium chloride, sodium chloride, potassium chloride, rubidium chloride, cesium chloride, which is more covalent pathina, lithium chloride is more covalent. In fact, it is soluble. It is not soluble in water. It is soluble in non-aqueous solvents. Okay, whereas cesium chloride is readily soluble in water. And then next, alkali metals are very strong reducing agents. Alkali metals are very strong reducing agents because they are ready to donate its electron. They are electropositive. They are ready to donate their electrons. So what about the reducing property? அப்படி பாத்தீங்கன்னா reducing property. Reducing property எப்படி change ஆகும்? Reducing property of alkali metals எப்படி change ஆகும்? So we are talking about how easily the electron can be donated by the metal atom. Okay, so lithium, smallest ion, cation, so it is not going to, smallest atom, it's not going to readily donate its electron. Ionization potential pathina lithium higher, followed by sodium, potassium, rubidium, cesium. So reducing property, as the size of the cation increases, reducing property also increases. So reducing property of lithium will be less compared to sodium, compared to potassium, compared to rubidium, compared to cesium. Okay, compared to cesium, this is the reducing property. Okay, next, now ammoniacal. Suppose if you take these alkali metals and put it in ammonia, liquid ammonia, then what happens? It forms a deep blue solution. A blue colored solution will be formed. That is because of the formation of ammoniated electrons. So what happens? This metal, we are going to put, let's say we are going to put the lithium into liquid ammonia. So lithium is going to dissociate into Li plus and E electron, and the Li plus ion will be surrounded by ammonia molecule, and electron also surrounded by ammonia molecule. Okay, so they become solvated. Since if you put it in water, hydrated. Here we have put it in ammonia, so ammoniated cation will be formed. Ammoniated cation and then ammoniated electron will be formed, and they are actually that is the reason it is actually paramagnetic. It is paramagnetic, and they conduct current because they form ions. Metal ion and electrons are there. Electron is highly conducting in nature, so this is a conducting solution. Okay, So this one is the deep blue color solution. Big deep blue is due to the presence of unpaired electron, and then that is ammoniated, and it's going to be a dipolar collision. Suppose if you increase the ammonia concentration, what will happen? If you increase the ammonia concentration, what will happen? This M plus ammoniated electron, they come together, close to together, and they will form an what is it? Like adduct. Both of them will come together, and then they'll stay together. Clusters will start forming because ammonia concentration is more. So what happens? They started forming clusters. When it forms clusters, it becomes what happens? It becomes a diamagnetic. Okay, so the pairing takes place. It becomes diamagnetic. Let us look at few other questions. Now there is one question. Explain why is sodium less reactive than potassium? Okay. Now we saw a reactivity of alkaline earth, alkali metals, and alkali metals. What happens? Reactivity down the group, it increases from lithium to cesium. It increases. Lithium is the least reactive, and so cesium is more reactive. So explain why is sodium less reactive than potassium? The size of the atom increases. Size of the atom increases. When the size increases, so what happens? It is easy to donate or remove an electron from the metal. Okay. So because of the size, compared to sodium and potassium, the size of potassium is bigger. So it can easily, the electron can be easily removed. That is given by ionization potential is less for potassium compared to sodium. So sodium is less reactive compared to potassium, or potassium is more reactive compared to sodium. And then another question which discusses similarities between lithium and magnesium. Lithium is in the first group, magnesium in the second group. There is a diagonal relationship between first group and the second group elements. It's very common. So why they are behave similarly means they are similarities. Some of the similarity properties, if you look at lithium and magnesium react slowly with cold water. They are slowly. Remember slowly. Other elements react faster. First one, they react slowly with water, and then oxides of lithium and magnesium are less soluble, and then oxides, lithium oxide are less soluble, and hydroxides. Another property is lithium hydroxide and magnesium hydroxide. They decompose at high temperatures. Okay, they are not stable. Whereas other hydroxides, if you take other hydroxides, so sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, they are stable. Whereas these hydroxide, magnesium hydroxide and lithium hydroxide are not stable. If you heat them at high temperature, they converted into their corresponding oxides. And similarly, nitrides. Lithium, when you expose to nitrogen, they readily reacts with nitrogen and form lithium nitride, Li3N. And then magnesium reacts with nitrogen and gives magnesium nitride, Mg3N2. Okay, Mg3N2, Li3N. So remember that one. Questions can be asked based on this. So what is, they may ask what is, they may put like magnesium formula is Mg3N2. So what is the formula for magnesium nitride? Or they put some X, somewhere you put X, what is the value of X, like that they can ask. And then lithium and magnesium does not form superoxide or peroxide. Already we saw lithium forms only oxide, whereas sodium forms mostly. You can convert the other. Suppose even if you just the condition and try to prepare lithium superoxide or peroxide, they are unstable. So normally lithium and magnesium, they form oxides only. They don't form peroxide. If you may force them to form, it will be unstable. So they don't form superoxide or peroxide. And then another lithium carbonate and magnesium carbonate. Okay, they are naturally covalent. They are covalent in nature, and they decompose on heating. Lithium carbonate will decompose on heating, produces Li2O, lithium oxide plus carbon dioxide. Magnesium carbonate also will decompose on heating, produces magnesium oxide plus CO2. And lithium bicarbonate is does not form. Lithium does not form bicarbonate, whereas sodium bicarbonate is there, other bicarbonates are there, and magnesium bicarbonates also highly uncommon. And MgCl2 and LiS, lithium chloride and magnesium chloride are covalent in nature. Other property, they are highly covalent in nature. They are soluble in ethanol. Even lithium chloride can be soluble in pyridine also. So they are covalent. Magnesium chloride and lithium chloride are covalent in nature. And then another property, deliquescent. Okay, they are deliquescent. Deliquescent means a substance which absorbs moisture and then becomes physical state will change. Solid will converted into liquid. Okay, and then these lithium chloride and magnesium chloride can be they are actually what is these ions can be obtained as a hydrate. Okay, so lithium chloride LiCl2H2O. LiCl2H2O. Sodium does not form hydrate, NaCl. Other metal halides or does not form hydrates. So lithium alone forms hydrates. And magnesium chloride, of course, that also exists as hydrate. A few other questions I want to discuss. Let us look at now. Let us look at discuss a few questions from the okay. Now, one question they asked, what the correct order of the mobility of alkali metal ions in aqueous solution? Correct order of mobility of alkali metal ions in aqueous solution அப்படின்னு கேட்டிருக்காங்க. Now I told you if நம்ம வந்து ion charge size of the cation பார்த்தோம். லித்தியத்துக்கு smallest size, cesiumத்துக்கு highest size. But if you put it in, if they form ions, or water kulla pota udane, what happens? Lithium will form hydrated form iron. So water molecules will come and attach to the lithium ion. So since lithium ion is the smallest and charge density is more, it's going to form a very big hydrated ion. Lithium hydrated ion is very big. Size rombo பெருசா இருக்கும். Lithium ion, pure lithium ion has size small, but when you put it in water, because that lithium ion has some small size and charge density is more, so it's going to attract many water molecules and size of the hydrated ion. Okay, size of the hydrated ion is very big. So as we go down the group lithium to cesium போகும்போது பாத்தீங்கன்னா hydrated size வந்து decrease ஆகும். Okay, lithium hydrated ion, I'm saying lithium ion is smallest, but lithium hydrated ion is very big, and so mobility will be less. Okay, size of the and if you size mobility of the ions, cation இருக்கட்டும் anion இருக்கட்டும், mobility, if the size increases, mobility decreases. So இங்க என்ன கேட்டிருக்காங்க, correct order of mobility of the alkali metal ions in aqueous solution பாத்தீங்க அப்படின்னா, so correct order of mobility. Mobility எதுக்கு ஜாஸ்தியா இருக்கும்? Hydrated ion. So hydrated ion mobility பாத்தீங்க அப்படின்னா lithium hydrated ion கம்மியா இருக்கும். அதுக்கப்புறம் sodium followed by potassium, then rubidium. So rubidiumத்துக்கு வந்து mobility ஜாஸ்தியா இருக்கும் because hydrated ion உடைய size கம்மி compared to lithium. So lithium, rubidium will have more, followed by potassium, followed by Na plus, followed by Li plus. So first option A is the correct answer. Okay, next, ionic mobility of which of the following alkali metal ion is lowest when aqueous solution of their salts are put under an electric field? Different way la கேட்டிருக்காங்க. எதுடைய ionic mobility of which of the alkali metal ion is lowest? Ionic mobility எதுக்கு lowest இருக்கும்? Lithium. ஏன்னா lithium is a very big ion, so it is going to move very slowly in the presence of current. Okay, and then which one of the alkali metals forms only the normal oxide? Normal oxide M2O on heating in air. Normal oxide எந்த alkali metal ion form பண்ணும் அப்படின்னு பார்த்தீங்கன்னா I told you lithium alone forms a normal oxide. Li, whereas sodium forms peroxide, rubidium, potassium they form superoxide. Okay. And then the ease of absorption of the hydrated alkali metal ions on an ion exchange resin follows the order. This is கொஞ்சம் twist பண்ணிருக்காங்க. Okay. என்ன கேட்டிருக்காங்க ஒரு ion exchange resin. What is an ion exchange resin? It's a resin where exchange the cation or anion. Anion exchange resin na anion exchange பண்ணிக்கோ. Cation exchange resin na cation exchange பண்ணிக்கோ. Okay. So they ask which one will be easily absorbed ன்னு கேட்டிருக்காங்க. Which of them will easily absorb? எது ஈஸியா அப்சார்ப் பண்ணும் அப்படின்னு பார்த்தீங்க அப்படின்னா now depends on the size. If the lithium is follows the order, which one will have ease of absorption of the hydrated alkali metal ion on an ion exchange resin follows the order, which one will have more, எது வந்து ஈஸியா அப்சார்ப் பண்ணிக்கும் அப்படின்னா whichever has hydration, whichever the big ion, with the big ion which is formed, it's going to be absorbed to the ion exchange resin, easier absorb ஆயிக்கும். Okay. So what happened, already we saw lithium வந்து hydrated size வந்து பெருசுன்னு பார்த்தோம். Okay. Now listen, the property changes. If conductivity la பாத்தீங்கன்னா அங்க conductivity of lithium hydrated ion வந்து கம்மியா இருக்கும் ஏன்னா சைஸ் பெருசா இருக்கு. இங்க வந்து ion exchange resinல when you exchange the cation, what happens if the size is bigger, it's going to exchange easier absorb ஆயிக்கும். Understand? If the size is bigger, easier absorb ஆயிக்கும். So absorption of hydrated alkali metal வந்து பாத்தீங்க அப்படின்னா rubidium கம்மியா absorb ஆகும், then followed by K plus, followed by Na plus, then lithium plus. Okay. And then ionic mobility, there are different ways, like the sequence of ionic mobility in aqueous solution. அப்படி ionic mobility எதுக்கு ஜாஸ்தியா இருக்கும், cesiumக்கு ஜாஸ்தியா இருக்கும் ionic mobility, followed by rubidium, potassium and sodium. Lithium இங்க கொடுக்கல. So anyway, this is the order. Ionic mobility will decreases from cesium to sodium. Now, in the case of alkali metals, the covalent character decreases in the order. எப்படி வந்து covalent character decrease ஆகுது அப்படின்னு நம்ம பார்த்தோம். Already I told you, covalent character, size of the anion பெருசா இருந்தா covalent character ஜாஸ்தியா இருக்கும். அதே size of the cation கம்மியா இருந்தது அப்படின்னா covalent character ஜாஸ்தியா இருக்கும் அப்படின்னு பார்த்தோம். So they have given nice formula. The covalent character வந்து directly proportional to size of the anion, inversely proportional to size of the cation. அப்போ decrease ordering கேட்டிருக்காங்க. covalent character decrease ஆகணும். covalent character decrease ஆகணும். So first வந்து high covalent character, least வந்து கம்மியா இருக்கணும். covalent character எந்த கண்டிஷன்ல decrease ஆகுது, இங்க என்ன சேஞ்ச் ஆகுது, M வந்து காமனா இருக்கு, பட் anion வந்து சேஞ்ச் ஆகுதுன்னு பார்த்தோம். Okay. So which one will have more covalent character? Anion. எந்த anionக்கு எந்த compoundல anion பெருசா இருக்கோ, for that particular compound the covalent character will be higher. So we know that. So F size பாத்தீங்கன்னா F minus is smaller, chloride minus, bromide minus, I minus. So I minus will be the biggest anion. So I minus compound will have high covalent character. Decreasing order பாத்தீங்கன்னா first Mi should come, followed by Mbr, followed by Mcl, and then Mf. Option C is the correct answer. Decreasing covalent character. Okay, covalent character decreasing order. Now this one again, we saw this one also. Alkali metals form salt hydrates by the direct synthesis elevator. The thermal stability of these hydrates. Thermal stability, these hydrates பார்த்தோம். Again we saw lithium hydride, lithium small cation, hydride வந்து small anion. Whenever there is a small cation, small anion, the compound forms a strong strong bond. Okay. Similarly, big cation, big anion, they also form strong bonds. Okay, ionic bonds. So what happens? Lithium hydride is the strongest bond. So thermal stability, lithium hydride will have more stable, followed by sodium, potassium hydride, rubidium hydride, and cesium hydride. Now, which of the alkali metal chloride forms its dihydrate? Actually, dehydrate dihydrate salt, NCl 2H2O. 2019 நீட்ல கேட்டிருக்காங்க. ஈஸிலி எது ஃபார்ம் ஆகும் நான் ஏற்கனவே இதில் பார்த்தோம். ஒன் ஆஃப் த கொஸ்டின் பார்த்தோம். அது வந்து லித்தியம் குளோரைடு ஃபார்ம்ஸ் dihydrate. Other alkali metal halides does not form hydrated salts. Okay, let us look at some of them. Okay, I'll stop here. Let us look at now let's continue this one. Let us look at the next question. The question next question is what is that they asked? Compare the solubility and thermal stability of the following compounds of the alkali metals with those of alkaline earth metal அப்படின்னு கேட்டிருக்காங்க. Okay, so what are the things? Nitrates, carbonates, and sulfates. Nitrates, carbonates, and sulfates. Thermal stability except for lithium nitrate, the nitrates of alkali metals get decomposed while heating strongly, which results in formation of nitrites. Okay, now this is another important thing. Now if you lithium nitrate thermal stability, we are talking about thermal stability. Lithium nitrate, if you heat பண்ணீங்க அப்படின்னா you will get lithium oxide and NO2 gas, nitrogen dioxide gas you will get. Whereas generally other metal nitrates, sodium nitrate, potassium nitrate, rubidium nitrate, cesium nitrate, நீங்க heat பண்ணீங்கன்னா you will get the metal nitrite, MnO2 plus O2 கிடைக்கும். So remember that one. So lithium nitrate is going to produce NO2. And like lithium nitrate, other alkaline earth metal எப்படி behave பண்ணும்? Lithium nitrate மாதிரி behave பண்ணும். If you heat that one, they form the corresponding metal oxides plus NO2 plus O2. Okay, so lithium alkaline earth metals எல்லாமே வந்து if you heat those metals, they form corresponding oxide, calcium oxide, magnesium oxide, and then NO2 plus O2, they behave like lithium. And then solubility, both the nitrate, alkali metal nitrate alkaline earth metal nitrates they are highly soluble in water. Nitrates are highly soluble in water. Okay, so what about the order? நம்ம order வைக்க முடியுமா? Suppose side nitrates வந்து பாத்தீங்க, of course all of them are soluble. So which is more soluble, which is less soluble பாத்தீங்க அப்படின்னா, again it based on the size of the cation. If the size of the cation is bigger, it's going to be more soluble. Carbonate. Now thermal stability of carbonates. Alkali metal carbonates are highly, very stable to heat. But lithium carbonate ஏற்கனவே அனாலமஸ் பிஹேவியர்ல பார்த்தோம். Diagonal relationship between lithium and magnesium பார்த்தோம். Lithium carbonates decompose ஆகுது. Okay, lithium carbonate converted into lithium oxide plus CO2. Whereas lithium nitrate இதே மாதிரி தான். அங்கே என்ன பார்த்தோம்? lithium nitrate lithium oxide plus NO2 plus O2 ஃபார்ம் ஆகுதுன்னு பார்த்தோம். இங்கே lithium carbonate is less stable. And then alkaline earth metals also they decompose on heating. Nitrate heat பண்ணாலும் they converted into oxide plus NO2. Carbonate heat பண்ணீங்கன்னா metal oxide plus CO2 produce ஆகுது carbonates. Now another thing, solubility. Lithium carbonate வந்து not soluble. Lithium carbonate is not soluble because well, move down the group, solubility increases. So ஞாபகம் வச்சுக்கோங்க, lithium carbonate ல இருந்து நாம போகும்போது solubility increase ஆகுது. Okay, lithium carbonate, and then we have less soluble, and then so I'm going to change into lithium into sodium, and then this one potassium carbonate followed by rubidium carbonate, then next one the cesium carbonate. So this is solubility of this carbonate increases down the group. ஞாபகம் வச்சுக்கோங்க. So lithium carbonate compared to lithium carbonate, cesium carbonate is more soluble. Whereas alkaline earth metals வந்து less soluble. Carbonates of alkaline earth metals are less soluble. And next property is thermal stability. Thermal stability, sulfates of both group 1, group 2 metals are highly stable. Sulfates of, now very important, sulfates of alkali metal sulfates are highly soluble in water. Again, same, just like the lithium carbonate mari, among the solubility pathinga appadina, it's going to be, so what I'm going to do, this one I'm going to SO4. So solubility of sulfate salts pathina, it's same, it forms the trends of carbonate udiya trend da ingeyum form agudhu. So sulfates are soluble, and the solubility increases from lithium sulfate to cesium sulfate. Whereas if you go to alkaline earth metal, only magnesium sulfate is soluble, calcium sulfate sparingly soluble, barium sulfate, beryllium is fairly soluble, and then magnesium soluble, calcium sparingly soluble, barium sulfate and strontium sulfate are insoluble. Okay, so remember that one. And then preparation of this one, let us look at. Okay, another important property pathina, structure of barium chloride, beryllium chloride and vapor and solid. Beryllium chloride vapor state, beryllium chloride solid state. Beryllium chloride has a linear structure and exists as a monomer in the vapor state. Vapor state la it exists as a என்னவா இருக்குது அப்படின்னு பாத்தீங்கன்னா, it is exist as a monomer. Whereas in the solid phase, okay, solid phase la it exists as a polymer. No, actually normal வந்து பாத்தீங்க அப்படின்னா beryllium chloride வந்து it exists as a dimer, students. So it is exists as a dimer, but high temperature it decomposed into a linear state. ஞாபகம் வச்சுக்கோங்க. Linear beryllium chloride has a linear structure in the vapor state at high temperature. At high temperature. Okay, ஞாபகம் வச்சுக்கோங்க. It exists as a high temperature ல அந்த மாதிரி இருக்கு. But others and all பாத்தீங்க அப்படின்னா it is small. Other இதுல வந்து பாத்தீங்க அப்படின்னா இது exist as dimer இருக்கு. Okay. Another question பாத்தீங்க அப்படின்னா, what is the another question? The another question, if you look at what they form. Now, because why are lithium salts commonly hydrated and those of the other alkali ions are usually anhydrous அப்படின்னு கொடுத்திருக்காங்க. ஏற்கனவே one question it came. Because of its hydration, lithium, because of the smaller size, it has what is it? Its hydration enthalpy is more. Okay. So lithium chloride exists as a dihydrated lithium chloride, whereas other salts are they are anhydrous salts. அதே மாதிரி why is lithium fluoride almost insoluble in water? Lithium fluoride நல்லா ஞாபகம் வச்சுக்கோங்க, the lithium fluoride is an ionic compound, but still it is insoluble, whereas lithium chloride is soluble in water as well as acetone. ஏன் பார்த்தீங்க அப்படின்னா lithium chloride is it's an ionic compound with high lattice energy. The lattice energy of lithium fluoride is very much high because of the smaller size of lithium plus as well as F minus ion. Both are smaller ions. So whenever there is smaller ions are there, they are going to form very, the lattice energy is going to be high. It means it is not easy to dissolve them. It's not easy to break them and bring into solution. So it is difficult. So lithium fluoride, even though it is an ionic compound, it's not soluble because of the high lattice energy. Whereas lithium chloride எடுத்துட்டீங்க அப்படின்னா, it is its lattice energy is not that high compared to LiF because chloride ion is comparatively bigger. So what happens? The hydrogen energy, lithium, in both cases, lithium is same size, whereas Cl minus is bigger. So because of that one, lithium chloride has what is it? It has lattice energy is less compared to lithium fluoride. So it is soluble. It is soluble in the water to some extent, but it is highly soluble in non-polar solvents also. So it has covalent character. Lithium chloride, don't forget, it has covalent character. That is the reason it can be solubilized in non-aqueous solvents. Now another question they have asked, the significance of sodium, potassium, magnesium and calcium in biological fluids. Okay, what are the way they are useful in biological fluids or in human body? They are found in blood plasma and interstitial fluids around the cells. So sodium help in transmission of nerve signals, and also water flow across the membrane is controlled by sodium. Transport of sugars and amino acids from within the cell to outside also is done by the presence of sodium ion. And potassium பார்த்தீங்க அப்படின்னா, they are help in activating enzymes. Glucose oxidase பண்றதுக்கு potassium is necessary, and of course transmitting nerve signals, both potassium and sodium they help. And magnesium and calcium பார்த்தீங்க அப்படின்னா, they are actually macro minerals or macronutrients. Magnesium uses பார்த்தீங்கன்னா, the relaxing nerves and muscles க்கு magnesium தேவை. And then bones க்கு we need calcium as well as magnesium. And then coagulation of blood க்கு we need calcium, and then homeostasis to keep the temperature of the body. Okay, next interesting question. Look at the next interesting question. How would you explain the following observation? Beryllium oxide is almost insoluble, but beryllium sulfate is soluble in water. Another one, barium oxide is soluble, whereas barium sulfate is insoluble in water. Lithium iodide is more soluble than potassium iodide in ethanol. Okay, in ethanol. அப்படின்னு கொடுத்திருக்காங்க. First, sizes of beryllium 2 plus O2 minus are small and highly because both of the size either beryllium 2 plus O2 minus, they are small. I told you whenever the ions are both anion and cations are small, they are going to form strong ionic compounds. The lattice energy is going to be very high, just like lithium fluoride, beryllium oxide. The size of both the cations and anion are small, similar size and small. They are going to form high lattice energies. The lattice energy is very high. So even if you dissolve, the hydrogen energy is less compared to lattice energy. So beryllium oxide வந்து நீங்க dissolve பண்ண முடியாது. We cannot, because lattice energy is very high. So it will not easily dissolve. Okay, it won't dissolve, insoluble. Whereas if you take beryllium sulfate, beryllium sulfate எடுக்கும்போது when you compare beryllium oxide and beryllium sulfate, anion size of the anion is much bigger, SO4 2 minus. The size of the anion is so big so that the lattice energy is not very strong, and you can, when you dissolve, it's going to split into Be2 plus, beryllium 2 plus ஆகும், SO4 2 minus ஆகும் மாறும். Hydrogen energy is going to excel, is going to be more than the lattice energy here in beryllium sulfate, and beryllium oxide lattice energy is very high. And similarly இது பாத்தீங்கன்னா barium oxide and barium sulfate பாத்தீங்க அப்படின்னா barium oxide is soluble, whereas barium sulfate is insoluble. Barium sulfate, barium, same thing like beryllium oxide, beryllium Be2 plus O2 minus same size mari, barium and SO4 minus, they are same size, they are big, and they are 2 plus and 2 minus, their size is bigger, and they are going to form a high lattice energy. Size நான் சொன்னேன், anion உடைய cation உடைய size equal இருந்தது, both are small or both are bigger இருந்ததுன்னா, they are going to form strong ionic compounds. Lattice energy is going to be higher. Same thing, beryllium oxide lattice energy is higher, barium sulfate lattice energy is higher, so it is insoluble. Beryllium sulfate lattice energy is less and hydrogen energy is more, so beryllium sulfate is soluble. Same barium oxide also, same thing, barium oxide also is soluble in water because of the less lattice energy compared to hydrogen energy. So lithium ion, the lithium iodide. Now another question they have asked, what is it? Lithium iodide is more soluble than potassium iodide in ethanol. இது ஏற்கனவே நம்ம பார்த்தோம். We arrange in covalent character. Ethanol is a non-aqueous solvent. அப்ப in ethanol non-aqueous solvent ல எது ஈஸியா soluble ஆகும் அப்படின்னா covalent substances are easily soluble in ethanol. அப்ப lithium iodide உடையும் potassium iodide நம்ம கம்பேர் பண்ணும்போது நம்ம பார்த்தோம், இங்க வந்து iodide ரெண்டுலயுமே iodide anion, and the big anion size பெருசா இருந்ததுன்னா it is going to form என்னன்னு பார்த்தோம், they are going to form, iodide is very big, cation is small, so they are going to form only covalent character is more. So compared to lithium iodide and potassium iodide, covalent nature of lithium iodide is more, so it's going to form covalent compound. It's going to be more soluble in ethanol. Okay, okay, I'll see you in another edition.